we're going to make the connection between the normal distributions that we've been looking at and probabilities. It turns out when a random variable x is normally distributed, you can find the probability that x will lie in an interval by calculating the area under the normal curve for that interval. So the important key words here is that we are connecting the probability with the area. So hopefully you took your time with section 5.1 and really understood how to go about finding areas for the normal curve, because now we're going to use that and make a very small leap into probability. What you see in the pictures on the right here is I have first a picture of a normal distribution, and it has that characteristic shape, it has the symmetry, and then below it I have the standard normal distribution. And once again, what the difference between those two is notice the normal distribution has a mean of 500, a standard deviation of 100, whereas the standard normal distribution always has the mean be 0, and then one standard deviation is 1. So what we can do is we know how to find the areas for this standard normal distribution. Using z-scores, we can take any normal distribution and standardize it, make it one of these so we can look it up. And here's how we do that. First of all, you're going to find the z-score or scores that correspond to the boundary of the interval you're looking for. Then you're going to use the standard normal distribution and the standard normal distribution table. I guess we don't need to say table twice to find the area. So in a national study, it found that college students with jobs worked an average of 22 hours per week. The standard deviation is 9 hours. So I'm going to pause and just record my mean and my standard deviation. A college student with a job is selected at random. Find the probability that the student works for less than 4 hours per week. Less than 4 hours per week is what we call the interval that we'll be looking for. It's an interval as opposed to a single number, because less than 4 hours could mean 4 hours, 3 hours, 2 hours, and so forth. So that is an interval as opposed to a single number. Assume that the lengths of time college students work are normally distributed, so that's telling you it's valid to apply properties of the normal curve here, and are represented by variable x. You will begin the process following the 2 steps we mentioned above. First of all, I want to find the z-score for the value that forms a boundary for our interval. I want less than 4 hours per week. So if we thought of that in terms of a number line, 4 is my boundary, and then I would want the interval to the left, the numbers that are less than 4. So I want to find a z-score that corresponds to 4, knowing the mean and the standard deviation. So remember, our formula is we take the value minus the mean and divide by the standard deviation. So a z-score of -2 corresponds to 4. So I want to know the probability. So I was originally asked to find the probability that a student chosen works less than 4 hours. That is equal to the probability of their z-score being less than -2. I can now find this probability by going to find the area from the standard normal table. So I'm at my standard normal table and I'm looking for a z-score of -2. So here is -2. And because it's exactly -2, that's the same as saying a z-score of -2.00. So in other words, I'm going to read all the way across this row to the 0.00 column. And The intersection is 0.0228. I need to think about what I've just determined. For a z-score of -2, have I found the values less than or greater than that value? Well, it's always the area to the left, which is less than. So this is going to be my answer. So that is the probability that a student would work less than 4 hours per week. So you can see that's only about a 2% chance, a fairly small number. So all you need to get used to is the idea that the area corresponds to the probability, and really this isn't too difficult. We're going to do another example to look at slightly different wordings to see how that affects things. So in example 2, we have a survey that indicates that for each trip to a supermarket, a shopper spends an average of 43 minutes with a standard deviation of 12 minutes in the store. So once again, mean 43, standard deviation 12. The lengths of time spent in the store are normally distributed and are represented by the variable x. A shopper enters the store. Find the probability that the shopper will be in the store for each interval of time listed below. Okay, so again, not one specific time, but for an interval, somewhere between 22 and 52 minutes. So if I want the probability that they spend between 22 and 52, the first thing that I will need to do is find the z-scores that correspond to these. So I need my z-score for 22 and my z-score for 52. And you should be able to pause the video, do the work yourself, and compare with mine in a moment. So we have z-scores of -1.75 and 0.75. I can now write an equivalent probability statement in terms of z-scores by saying, instead of looking for scores between 22 and 52, I'm looking for them to be between the z-score that corresponds to 22, which is -1.75. I'm going to put less than x. And then the upper boundary, 52 minutes, corresponded to 0.75. So this is the way that I would write I want x values between these two z-scores. And the symbol should point this direction because I have the smallest z-score on the left and the largest z-score on the right. Again, you just need to remember that this is going to correspond to an area. And since we want to do between two values, I'm going to need to find the area for each z-score and then subtract them. And again, I'm going to skip over jumping to the table and looking them up because you should be able to do that. When we look up -1.75, we get an area of 0.0401. And when we look up 0.75, we get 0.7734. So to calculate the area, I am going to subtract always the bigger area minus the smaller area. And when you do that, you get a probability of 0.7333, or approximately 73% chance. So there's a 73% chance, based on the data that we have so far, that a shopper will spend between 22 and 52 minutes. Now, there's another example which is more than 37 minutes. So in everyday English, I'm looking for the probability of x being more than 37 minutes. I need to write an equivalent probability statement using the z-score for that boundary. So my z-score of 37. So the z-score for 37 turns out to be -0.5. So I want to know what's the probability that my z-score ends up being bigger than -0.5. Now, here's where you have to be careful. When we want a less than, we can go straight to the probability table and look it up. So less than, we want the shaded area to the left of the z-score. When we say more than, what we're really saying is we want the area to the right. And if that's the case, I'm going to need to find this by doing 1 minus the probability of z being less than negative 0.5. So in other words, find the probability from the table, which is this. So this is the information you get on the standard normal table. So when I look up negative 0.5, I get an area of 0.3085. So I now need to finish by doing 1 minus that number, giving me a final answer of 0.6915, or approximately a 69% chance. Now we can add on an extension to this, which is the part B here. Part B says, when 200 shoppers enter the store, how many shoppers would you expect to be in the store for each interval of time listed above? We found the probability that they spend somewhere between 22 and 52 minutes to be 0.7333. And we found the probability that someone spends more than 37 minutes to be 0.6915. Those, again, correspond to just the percentages of any group. So if you have 200 shoppers enter the store, all you need to do is take the probability that someone is going to stay for that interval of time, multiply it by 200, and for the first one, you're going to get something in the neighborhood of 146.66. But keep in mind, these are shoppers, so we really want to round that to the nearest whole person. So we know we could expect about 147 shoppers to spend 22 to 52 minutes. And you can see how that would be useful information. Same thing for determining how many of the 200 are likely to be in the store for more than 37 minutes. Once you know the probability, just multiply that by 200. You're going to get 138.3, which we're going to round to the nearest shopper. So 138 shoppers will spend more than 37 minutes. So this is a very powerful prediction tool. If you have a data set that measures some previous behavior and it's normally distributed, you can then go and make a whole myriad of different predictions about future behavior. And before we leave this section, I just want to remind you that I did post a video on how to use Excel to look up these area values. You're welcome to use either the standard normal table or use Excel to get your areas.